Assalamualaikum warahmatullahi wabarakatuh and good morning. So today we will present mini project analysis of DC-DC boost converter circuit from subject power electronics. So first of all, my name is Amal haziq bin Azizi and Afiq bin Khairulnizam and Muhamad hafizzi bin Mustafa Azizul is my group mates. Objective of this mini project first is to explain the significance of using gate driver for converter circuit. Next, to understand the principal operation of boost DC-DC converter circuit. Lastly, to analyze the boost DC-DC converter performance under variations of parameters.
Assalamualaikum warahmatullahi. My name is Muhamad hafizzi. So now we are going to discussion of the circuit operation and analysis. So this is the state where the switch is on and conducting and the diode is off. When the switch turn on, the initial high frequency square wave will apply to the pulse generator at startup. During this time, a short circuit happens at the right hand side of inductor. The output capacitor stays charged since it can't discharge through the left hand side due to the back bias diode. Therefore, a current flows between the positive and negative supply terminal through inductor, which stores energy and its magnetic field. Next, for the state which the switch is off and conducting and the diode is on. The current of the inductor is stopped abruptly. The inductor now acts like a voltage source in series with the supply voltage. The inductor generates a large voltage with the opposite polarity of the voltage, originally supplied to it using the energy stored in the magnetic field to maintain the current flow. Next, the anode of the diode is now at a higher voltage than the cathode, which means it is forward biased. And the output capacitor is now charged to a higher voltage than before, which means that we have successfully stepped up a low DC voltage to a higher one. So this is our experimental result. For duty cycle signal, it goes from 0 to 1. And for current output waveform, it goes from 0 to 140. And here we can see the steady state response of the current output waveform. And this is our experiment result for voltage output waveform. It goes from 0 to 300. And we can see here the steady state response for this voltage output waveform.
Hi, Assalamualaikum. My name is Afiq bin Khairulnizam. Okay, today I may explain about how we get the calculation. Okay, first how to search output voltage. So the formula that we need to use is V output equal to V input per 1 minus duty cycle. Okay, next we move to the output voltage ripple. So the formula is delta ripple. Right, next we move to the output voltage ripple, which is the equation is duty cycles times voltage output per resistance times capacitor and frequency. So we calculate it and we got a 0.57 volt. Next we move to the inductor currents, which is voltage input per 1 minus duty cycles square times resistor. So we calculate and then we get the 25 ampere. So the task asks us to find the inductor currents, the minimum and the maximum. So the formula is voltage input per 1 minus D square times resistance minus voltage input per duty cycle times per 2 inductor. So the answer for inductor current minimum is 24.375 ampere and the maximum one is 25.625 ampere. Thank you, that's all from me.
For conclusion for this mini project, after all the tasks that has been done, we can summarizing what the point of this mini project and what to need to be highlighted. The DC boost converter can step up DC voltage level to another level and it is widely used for many applications. So after we simulate the task given at Simulink, we can conclude that when the booster in the on state, inductor will increase, and when it in the off state, inductor current is through the flyback diode, capacitor and the load, so this will result in transferring the energy accumulated during the on state into the capacitor. So what we learn on class can be applied in this mini project and theory are true.
That's all from our group. Thank you and stay safe.